Today, I'm going to be showing you how to build an end-to-end AI agent using Langgraph. By the end of this video, you'll have a data analyst that you can use to query any data, perform deep data analysis, and generate some beautiful visualizations. So whether you're interested in building agents for your own personal productivity, for your business, or for the company you work for, I'm going to give you a foundational understanding of Langgraph's core concepts so that you can start building your own amazing agents for your use case. My name is Kenny, and I've been building AI systems and working with Langgraph for the last 2 years, and I'm really interested in going beyond the docs and toy examples that you see. I want to give you helpful content for real-world production use cases. So if you enjoy this video, definitely subscribe and turn on notifications for the next one where we'll be deploying this agent to the cloud. Before we get into any code, I want to kind of zoom out and talk about what Langgraph is, why you would use it versus just building from scratch, and why you might use Langgraph over other frameworks. At a high level, Langgraph is an agent orchestration framework. It's an open source library. On the website, you can see they kind of describe it as what you would use to ship powerful production-ready AI apps. There's so much that goes into building an agent, especially one that you're going to serve to customers or make scalable and production ready. For example, how do you handle multiple tool calls, parsing tool calls from API requests? How do you handle handoffs or agent-agent interactions, tracing? All of that is kind of built into Langgraph, so it just makes it really convenient to build with. You don't have to worry about a bunch of low-level code. You can just jump into how you want these agents to talk to each other and building in your business logic. Other things that Langgraph helps you manage is with, I mentioned, tracing and observability so that you can evaluate your AI systems. Also handling, for example, human in the loop. So how do you control certain tools that the LLM might be calling and have a human approve or reject a tool call? Also with persistence and maintaining conversation histories or even artifacts that are produced by your agents. How do you persist that in a database? So a lot of that is handled by Langgraph, and they have a whole ecosystem for it. Now, kind of getting into whether Langgraph is the right solution for you or not. If you have never tried a framework and are thinking about using Langgraph versus building from scratch, some considerations might be how much control do you want to have over your application? Do you want to minimize abstraction? Is it important for you to understand what's happening under the hood? Maybe your use case is really simple and it doesn't actually require that many features that a framework has to offer. All of these reasons would be good for you to just go ahead and start building with the LLM provider APIs directly. And that removes, again, a lot of the overhead that you have from using a big library like Langgraph with a ton of features that you're probably never going to use. It's another learning curve. That said, on the other hand, reasons for why you might want to use a framework, as in my case, you have a more complex use case. So what I'm building for my business is related to data analytics. That's what my background is in. And there are a lot of agents that I have to manage, a lot of workflows, and the complexity kind of blows up. So if you were writing all of that from scratch, it would be really difficult to manage. I'm not going to be writing in all of these optimizations around the code that the Langgraph framework is going to have. And it is open source, so there's a big community working on it. The framework also offers a bunch of features and functionalities that I wouldn't necessarily be able to implement myself. It also lets you get to production faster because you are abstracting a lot of the low-level code, so you can write huge chunks of functionality with a simple function or one line. And then again, it's a full-featured ecosystem, so it's not just about writing the code for the agent, but introducing all of these other tools like tracing and observability, hosting on the Langgraph cloud, all of these things that make it really convenient to get to a finished product faster. Okay, so you've decided that you either need a framework or you don't. But if you do, why would you use LangGraph versus other frameworks like AutoGen or Crew AI? I'm going to give you my take, but of course it's worth figuring out what makes the most sense for you. Just in terms of the community and support and adoption of these different frameworks, LangGraph is kind of the behemoth in this space. Interestingly, if you go to the GitHub repositories, you'll see that LangGraph has 12,000 stars, whereas Crew AI has a lot more. It's got more than double, actually. But interestingly, if you go down to the used by section, you'll see that Crew AI just has around 14,000, while LangGraph has around 23K. So it almost flips, where you have twice as many projects on GitHub using LangGraph. It's also interesting when you go to look at the download stats. So LangGraph monthly downloads exceed 25 million, whereas Crew AI is down at 6 million. So just in terms of people using LangGraph versus Crew AI, LangGraph is definitely much, much higher. AutoGen is not even close. It's less than 1 million. But LangGraph does have a really active community. So a lot of support. And if you look at the companies that are using LangGraph, these are huge companies, right? You have GitLab, Replit, Cisco, Home Depot, LinkedIn. So it really is kind of the big player. And I think it does look like it has a bright future. For me, it's also the ease of use and the full featuredness of the library that makes it really useful for me. Let's talk about the data that we're going to be working with. It's for a company called OnlyVans. That's a streaming platform, and this streaming platform is exclusively for content creators that want to make content around van life. So these are van builders. They live in vans, they overland, and they're going to be generating a lot of amazing content for true van fans. So obviously we've got the van here on the left, and I've included some examples of revenue streams for these content creators. They can, of course, have subscriptions of different lengths. So any customer or viewer that goes onto the platform can buy a subscription, and they can also tip the creators or buy exclusive content like pics and videos and other things. So that's how our content creators will generate revenue on this platform. So you've got the 3 tables here. The creators are the ones that are streaming on the platform and generating the content. Then you've got the customers, which we can also refer to as viewers. And then you have, most importantly, the transactions table, which is going to be an individual transaction, a single transaction between a customer and a creator, where the customer is purchasing something from that creator. So it could be, again, exclusive content. It could be a subscription. Apparently we have sticker packs, and you also got the tips there. So that hopefully gives you a good idea of the data we're going to be working with. Okay, so let's start with a demo of what we're going to be building today. I mentioned it's going to be a data analyst agent, and this agent is deployed on the cloud. We're going to be interacting with it through a super basic interactive Python kernel, which is kind of like you can think of as our front end. But we're going to be chatting with this deployed agent. We are greeted with this message from Scout. Scout is our data analyst agent, but we want to start digging into it. We can just say, show me a preview of the data. And the name Scout and everything about this agent, of course, can be configured in the system prompt. But right away, what you'll notice is that we have streaming enabled. So we're going to build this agent and have streaming tokens to the front end. The other thing you'll see is that there are tool calls that are also streamed. So anytime the agent makes a tool call, we're going to stream that to the front end. And this is super important to have visibility into what the agent is doing. As a more advanced topic that we'll cover in a later video, this is also important to be able to see what tool the agent wants to call, be able to either reject or approve it, or adjust what the inputs are to the tool that the agent wants to call, and that's called human in the loop. So Langgraph also has a great way of implementing that. In this case, it's just going to call the tool and then stream what it's putting in as arguments. And this QueryDB tool is a SQL query that it can run by just passing in this query parameter, which is a SQL string. You'll notice it does it 3 times because it realizes we have 3 different tables, and the schema for this database is in the system prompt. So it knows it has this context, which is really important for the agent. Once it executes the SQL, it gets that output from the tool, and then it's able to summarize those first 5 rows in each table for us. So here we can see the first 5 rows of each table. And then we can just get into some analysis by asking, I want to do something that joins the table here. So we can say, who are the top 3 creators by total revenue? And so to do this, it has to join the creators and the transactions table. And you'll also see that before the agent does anything, it first writes out a plan that is again configured in the system prompt, as we'll see in a bit. So once it figures out what it wants to do, then it will, in this case, again, it's going to call the QueryDB and pass in the SQL, and then it's going to get the top 3 creators by revenue, which is pretty easy. Now I want to ask it to generate a visualization. So let's say plot their total revenue over time, because I want to see a line plot and something a little more complex than just like a bar plot. It's going to call now a new tool, generate visualization, and you can see this one takes in different query parameters. So it's passed in a name for the visualization. It's passing in the SQL query, which is going to allow it to pull the correct data for this. And then the last one is some code to generate this plot. This looks pretty nice, right? So now we can see the monthly revenue over time for these creators. The plot is interactive. I want to make this a little nicer where we can see how these creators have grown over time. So I'm going to say, or make this cumulative. You'll notice in a lot of these queries, I'm just referring to the past conversation. I'm not necessarily telling it from scratch what I'm trying to do each time, right? So we have memory and persistence also built into this agent. So it's going to have all of the context of the entire conversation. So you can say things like, show me the revenue over time for these creators. So now we get this really nice cumulative plot, and we can see what the revenue for these creators has been over time. But let's say we want to do even something more complicated where now I want to compare year over year. So I'll say I want to compare these series year over year. So overlay 2023 and 2024 for each creator. So then it'll go off and do that. Interesting. That's not quite what I was thinking, but it did separate the 2. I actually want all of the lines on the same x-axis. So do it by month of the year. Let's see if that works. And yeah, this looks right. So now we can look at Michael and how he did in 2023 versus 2024, which it looks like he had some significant growth in the second half of 2024. So yeah, you can see how powerful this is and how quickly you can just analyze, really complex data without having to write any of the code yourself. So I wanted to go back to this original plot that we asked for because I noticed that it had called this generate visualization tool twice to make it. And it's because it got an error the first time. It tried to use this date trunk function in the SQL, but it realized that transaction date is actually stored as text and not a date. So it had to make an adjustment there. It casts that data to a timestamp, so then it can actually use this date trunk function. So this is a super important concept. The agent is able to react If you've heard of that style of agent, a React style agent, whatever work it does, it can reflect on the outputs and then make any adjustments if needed. So it figures out its own errors and then tries to correct them to eventually complete the task. And so this agent only has two tools, like we saw in this generate visualization and the query DB tool. It only has two tools, but what makes it super capable is the fact that it can use these in combination and also react and fix any errors that it gets along the way, and plan out its steps. So it's a super simple example that I think will be easy to understand and learn, but also really powerful. And you can see how just adding, let's say, one or two more tools or capabilities to like write Python code and execute code would make this even more powerful. Let's cover two core concepts which are super important to understand when it comes to Langgraph, which is state and graphs. Agents in Langgraph are represented as graphs, and state you can think of as an object that stores all of the data from our interactions with the agent. I'm showing you a really simple example where we're going to keep track of three different data. One is messages, code, and then code approved. So this is an example for a coding agent. It's a simple Python dictionary. And really, that's the mental model I want you to have when thinking about state. It's just a dictionary. You can get into more advanced topics, which for Langgraph, the state object has to be JSON serializable. I won't get into why that is, but essentially any dictionary that can be represented as a JSON can be a valid state. So you can also have a typed dictionary, a Pydantic class, which we'll see in the code in a bit. But yeah, this is the simple mental model that you should have. It's a Python dictionary where we can store data from the interactions with the agent. Now let's talk about graphs. Here we have one for a coding agent. At the top, we have our state Python dictionary. The two main concepts for graphs are nodes and edges. Nodes are represented here as these white boxes. Edges are going to be the arrows that connect them. We have two different types of edges. You have solid arrows and dashed arrows. Solid arrows are your normal edges, and those are going to be fixed paths. Here we see one between generate code and review code. We also have one between the start node and the assistant. So in all these cases, whenever we get to one of these nodes, let's say with the starting node, we have to traverse the graph to the next node that's connected here, which is in this case the assistant. So similarly with generate code, if we get to this node, we only have one path and we have to move to the review code node after this. For conditional edges, you have two or more options for where you can traverse next. If you're at the generate code node, you have to go to review after. But once you're at review, you can either go back to the generate code node or you can route back to the assistant, in which case the assistant would decide what to do next, since you have multiple conditional edges coming out of the assistant. And one key idea here to understand is that these conditional edges or options of what the agent can do next really is what makes this an agent, right? So if you think about an agent, it needs to have agency, meaning it needs to be able to decide and have control over its actions and what it wants to do next. This whole graph that you're seeing here is what we're calling our agent. So this represents the agent in Langgraph. And so when we interact with the agent, what we're essentially doing in Langgraph is we're gonna update the state. So you can imagine we're gonna send a query to the agent. And that really means as soon as we get a query, we're going to add the first message to that list. And then we're going to pass in this whole state into the graph. And the graph is going to take that state through the start node, and it's going to pass it because it only has one option to the assistant LLM. Then the assistant can decide what it wants to do next. If it wants to route to the generate code node, it can do that. And the way it's going to do that is it's going to add its own message, either a response back to the user, or like I said, it could be a tool call. And so we would update the messages key to now add a second message, which is from the assistant. And then we would traverse the graph over to the generate code node. Once we get to the generate code node, this node would generate code and then update the code key in the state. And so this would start out potentially blank because we don't have code when we're first starting out. But once this dictionary again gets routed to the generate code, we're going to generate some code and then we're going to update that state variable. And then once that's done, we again have a normal edge, and so the state has to be passed over to the review code. The review code would determine if we're going to approve this code or not, and it's going to update the code approved key in the state dictionary to either be true or false. And that's where you have now this conditional edge, where if it's true and the code is approved, then we're going to pass that back to the assistant. Whereas if it's false, it's going to route back to regenerate the code in the generate code node. And you would kind of go through this review loop until the code is finally approved and we can send that to the assistant. And then finally, the assistant would look at the output from the code, realize, okay, we have some code generated. It does what it's supposed to do. It's going to respond to the user with something like, hey, we generated the code and it looks good. And so it's going to send that response to the end node or the state, and then that would be returned to our front end or the user. So this is the mental model you can be thinking about as we interact with our agent, as we build out our graph. You have that Python dictionary just being passed around through each of these nodes based on how we define the edges. Quick plug, while I have this open, this is a Notion cheat sheet that I created for this particular episode, and it's got a ton of more information than what I'm going to be actually going through today. It's got diagrams, it's got touches on advanced topics for each of the things that we're going to be talking through. I've done the courtesy of having like the main takeaways highlighted and everything, and then added a bunch of resources. So every time I release an episode, it will come with a cheat sheet. If you're interested in getting this free Notion template, feel free to sign up for my community. It is completely free and just takes your email. I'm going to be sharing a lot more exclusive content for you guys that will hopefully bring a lot of value. The link will be in the description, and I hope to see you there. All right, so let's walk through the setup so that we can get you up and running. The first thing you're going to want to do is go to the repo on GitHub, which will be linked in the description below. And you can just follow the README. It's pretty detailed. You're going to want to follow the entire setup section and just make sure you do every step. We're going to go through this together. You're going to want to start by forking the repo, and you want to fork and not clone, because if you do eventually want to deploy it, then you're going to have this published on GitHub. You can click on this fork button here. It's just going to ask you if you want to rename it, but basically you're copying it over to your own GitHub. I'm just going to hit create fork, and we should have a copy on our own GitHub in a few seconds. Once it's copied over, you can just clone it to your local machine. So we're just going to copy this and then go over to VS Code. Okay, so once you're over in VS Code, you're going to want to navigate to the folder where you want to clone this and create the project. Just go ahead and do git clone, paste in the git. We're going to be using UV for this project. It's a package manager for Python. It's super fast for setting up environments, and it's just really convenient. If you don't have UV installed, go do that first and then come back here. You're going to want to cd into the actual project directory that we just created. And then you're going to run two commands. You're going to run uv venv. That's going to create a new virtual environment inside of the project folder here. So you can see it is already picked up by git ignore. So it's going to be grayed out. And the next command we can run is uv sync. And what that's going to do is it's going to install all of the required packages. It's reading them from this PyProject toml. So if you're interested in what's actually, what are all the dependencies in this project, you can see them here. We have some dev dependencies that are also installed, including the Langgraph CLI and IPy which is going to be required to run some of these code snippets in interactive mode. So we need to run one last command, which is going to be uv pip install -e dot. Make sure you have this dot at the end. And what this is going to do is it's going to install the current folder or directory as a package. So it's going to install our project as a package itself. And that just makes it easier so that when we change any code, it'll automatically be reflected in our package. And that way we can also, as we get into some of these files, like if I just open this graph.py, you'll see that we can use Scout as a library, right? So we're importing it from this Scout module. And that's because we ran this uv pip install for the current project. Okay, so the next thing we're going to want to do is set up our environment variables. You're going to take this and you can either make a copy of this and then rename it, or we can just use the example directly and remove this example part in the name and then just do .env. And we'll just go through and fill these out in order. We're going to hop over to Supabase first and make an account. All right, so once you've made an account on Supabase, you might not have any projects here, but either way, you want to create a new project and you can title this OnlyVans. And then I would just use the generate password here. It makes it convenient. You're going to want to copy this and hit create new project. That's going to take a little while to spin up. While it does, you're going to want to hop over to VS Code and save the password. So we'll just paste that in at the very top and then hit save. And then we'll go back to Supabase. Hopping back over to Supabase, you can see it's setting up the project. Oh, it looks like it just finished. The next thing we're going to want to do is get the connection strings to our database. You'll see at the very top, there's this button that says connect. So you're going to click on that and there's 3 different connection options. We're actually going to be using 2. And I'll explain why we need 2 in a bit, but you're going to want to copy the session pooler session first. So it's got the whole connection string here. You can just copy that. And for the session pooler, we're going to paste that into the database URI. There's a placeholder for your password. So you're going to want to copy that over and replace everything, including the brackets, to get your password in there. Then we're going to hop back over to Supabase and get the transaction pooler. So the transaction pooler is the second one. We'll copy that and then save it in the env file. And this one is going to go into the Supabase URL. And again, we're going to have to copy over our password, replacing that placeholder. So the reason why we have 2 connection strings is the session pooler is going to be used exclusively by the Langgraph server once we deploy our agent. The Supabase URL is where we are going to connect, where our agent is going to be connecting to our database to query data. So that's it for Supabase. The next one is OpenAI's API key. So you're going to want to hop over to platform.openai.com. And if you don't have an account, make an account there. You're going to click on dashboard in the top right. And then go to API keys on that left menu. And then you're going to want to create a new key, name it whatever you want. You can call this OnlyVans, create new secret, and then copy this and throw it in your env file. The next account that we need is a Langsmith account, and this is going to be for tracing and observability. And I highly recommend not skipping this step, because when you're trying to debug and figure out what's going on, or even just optimize something like your system prompt, you really need to be able to see every step that's happening within your graph execution. Langsmith allows you to do that pretty easily and conveniently. All you have to do is get an API key. So you're going to want to go over to smith.langchain.com, create an account, and then on the side menu here, you'll see settings, go to settings, and then click on API keys in the left, and then you can create a new API key and then throw that into your .env file. Okay, so once you put in your Langsmith API key, you should see an env file that looks like this with everything filled in except for the Redis URI and the Langgraph server URL, which will come later when we are ready to deploy. For the Langsmith settings, there are 4 settings total. You just paste it in the API key, and 3 others are already preset for you. You have the endpoint, and then you have tracing set to true along with the project name. So this will automatically log everything under a single tracing project. Once you're done with setting up the environment variables, we're going to hop back over to Supabase to set up the database. And you're going to want to go to the side menu here. You'll probably be on the project overview. You're going to want to click on table editor. This defaults to the public schema. You shouldn't have any tables here. We are going to create a new schema, so you can click on this drop down with the schema and create new schema, and then just call this OnlyVans. And we'll hit save. And we're going to make it so that all of the tables that we're going to use for our project will be under this schema, and we will direct our agent to just specifically query this schema. So we're going to add the 3 tables, starting with the creators. And you're going to want to name the table and then hit this import data from CSV. This is just going to make it really easy so that you don't even have to define the schema. It'll just read it from the CSV. So on your computer, you'll want to find the 3 data files, which are going to be in the sample data directory. And then you can't see this on my screen, but I'm dragging that creators file, the CSV, into this. So you can see it's the creators 2023 CSV. So you can just drag and drop it there. It's going to load the data and then automatically get the column name. So it just makes it really easy. You can hit save, and then you have to do one last thing, which is to let Supabase know what the primary key is, because every table needs a primary key. So I can just check that box on the ID, and this table is set up. So if you hit save, it's going to create that table and load the data. And you're going to want to do the same thing for the next 2 tables. So it'll take a little minute. So here we have our creators table. In between setting up your tables, just make sure that each time you are on the correct schema, because I've noticed that sometimes this changes schema by itself once I upload a new table. So just make sure you have OnlyVans selected there, and then do the same thing for the other 2 tables, starting with customers. And then let's really quickly talk about the structure for this project. You've got a few folders. One is the front end. This is where I ran the chat with our deployed agent. So that was the demo. You also have a chat local, which will allow you to interact with the agent running locally. So running Langgraph within your terminal. Then you have sample data, which is going to have the data that we're populating into Supabase. This is the data we're going to be querying. You have Scout, which is actually all of the Langgraph files. So this is what goes into building our agent, who is called Scout. So let's look at the system prompt. I like to normally create a separate folder for prompts, where you can imagine if we had multiple agents here. Right now it's just Scout, but I might have 4 or 5 agents in here, and each of them would have their own markdown file where I can really write a nice organized system prompt, and I would have that for each of my agents. Then I have a single prompts.py file that would load each of these into the global variables. And remember, we installed this whole package as a module. We can import from Scout prompts, and this prompts file or prompts module will give us access to these system prompts as variables. So let me show you what that looks like. So here we have from scout.prompts, import prompts. And then now if I go down to where we're passing in the system prompt, here you can see when I initialize this agent, I'm just typing in prompts.scout system prompt. And so that's the prompt that we're loading here. We also have an env.py. This is just to initialize all of the environment variables that are required for the project. We also have a check just to make sure that the minimum required environment variables are loaded, and that's for the Supabase URL and the OpenAI API key. And then so we're just going to raise an error if we don't find at least those two. So if you start getting this annoying error down here, just make sure you select the Python interpreter. If you don't see it right away, you can click on enter interpreter path and then find, and then just go ahead and find the v&v folder that we just created, and then that should make the interpreter errors go away. If you're on Windows, actually, you're gonna have to go into the .venv, go to scripts, and then scroll down and choose the Python executable. In every Langgraph project, you're always gonna have a state, graph, and tools. I like to organize things and kind of separate them out, because as you scale up your agents and then even add, multi-agent systems, it will get really complicated. So typically I like to separate tools into their own file. So you can see here, we'll get into what exactly we're doing for this particular agent, but then the graph would be in its own file called graph.py. In this case, I'm just including the state because it's a super simple state. I'm including it in the graph.py file as well, but in larger projects, I would actually create a state.py file and then separate this out. All right, so let's dive into the graph.py file, starting with the state that we're defining for our agent. It is going to be a Pydantic class, and if you've never worked with Pydantic before, you just import this base model class from Pydantic, and then you create a new class that inherits from that base model class. And what this is going to give you is strong type validation for whatever you're defining here. You can still think about this state as a dictionary object, but we're going to be adding type definitions for each entry in this state. So I have my messages key here. Annotated just basically allows you to pass in a type that messages should be, and then you can additionally pass in this method for how that type should be updated. In this case, we're importing add messages, which comes from Langgraph. And this is just a method of telling basically our state, how do we want the messages to be updated? If we pass in any new set of messages, it's just going to add the messages to whatever's already there. So it's essentially going to append the list of messages. So here we initialize it as an empty list. Chart.json, on the other hand, is just a string, and we're initializing it as an empty string. So let's see this in action. If we create an instance of this, okay, so we need to first execute all the lines above. And since we're using the interactive Python terminal, we can just highlight the rows that we want to run one at a time. So now that's initialized, and we can inspect it by highlighting just that state variable and then hitting Shift Enter. You can see we have a scout state instance that has an empty list messages and an empty string chart.json. We could also initialize this with values. So we can say messages is equal to, and so let's see what that looks like. So here, this is where you see an example of the type checking and type validation. We get one validation error for messages, specifically at the location 0, so the first item in the list. The input should be a valid dictionary or instance of base message. So you can see that not only should this be a list, but within the list, it can't just be a string. It has to be a type of base message. And base message is coming from langchain core. It is just the base type of message for all messages. So when you look at human message or system message or an AMI message, all of those build upon the base message. If we were, instead of passing in the string hi, we passed in a human message, and if we run this again, we can see now we don't get a validation error. After we initiate this, we could also pass in the key for chart.json and initialize this with, this is the chart.json. And because that it really is just a string, we don't get any validation errors here. We can inspect the state object, and then we see that we have this initial value here. So that's what the state looks like. And I mentioned it has to be JSON serializable. So what we can do with Pydantic is we can always dump a model into a JSON string by calling model dump JSON. So if we run that, we get back a JSON string. And to make this look nice, you can pass in indent equals to 2. And then instead of just returning the object, we can print it because it is a string. And then now we get this nicely formatted JSON. So you can see we have our messages key and our chart JSON key. And in the messages, it's a list with only one message type or one message. You can think of these other messages like human message, AI message, system message, classes as just other Pydantic objects. When we run the model dump JSON, we can see underneath the hood what they look like as JSON objects. So you can see this human message has these attributes. Content is the actual message, and type tells you that it is a human message and not an AI message. For example, let's say we add an AI message that says hello and then rerun this. Now you can see we have two messages. Here's our human message and here's our AI message. And these, again, it has nothing to do with the APIs for OpenAI or any of the LLM providers. This is just a langchain thing. Now, if you really wanted to, you don't have to have this requirement that I've added to my Pydantic state where I say this has to be a list of base messages. You know, you could say that this just has to be a list of strings, or it has to be a list of anything that you want to put in here, like a dictionary, right? So you could do that and you wouldn't have the error when you don't put in this exact human message or AI message type. You could do something like, and then you could instantiate it that way. I just find it a lot cleaner to not be writing these dictionaries and JSONs, to be able to pass in a class like this and then also have it do the type checking, because you can imagine if I pass in a dictionary, like in this example, I can't validate what values are in that dictionary without writing a bunch of code, right? So if I just pass in this base message requirement, I know that it has to be one of these types, and that just makes it a lot easier, again, for validating the data that's being passed through the graph. So that's a bit more of an advanced topic, but I highly recommend kind of getting a hold of that early on so that you're building all of your applications with a really strong base. Okay, so that covers the state object. Let's bring in now the LLM, and to do that, we're going to use from Langchain's OpenAI adapter, the chat OpenAI class. And this is just a wrapper really around the OpenAI SDK. And it just makes it a little bit easier to interact with these models, especially within the Langchain and Langgraph ecosystem. So the way we can instantiate it is just by passing in the name of the LLM, and our agent's going to be called Scout. So we'll just do Scout. And then you want to pass in the model. The model that we're going to be using today is going to be the Chat GPT 4.1 mini model that came out not too long ago. This model is super capable. I've found that it's really good at tool calling, and so it's definitely my go-to right now. It's also relatively cheap. So we can instantiate an LLM like this, and the way that we can interact with it is by calling invoke. Like everything in the Langchain ecosystem, we can pass in a message and say, hi. And as long as we have our OpenAI key set in the environment variables, which we did earlier, you'll get a response here. So everything that is sent to and from the APIs is going to be in the form of a Langchain core message type. So this is an AI message that we get back, and you can see the content here along with a bunch of other metadata. Okay, so now that we have our state and we know how to set up an LLM, which is going to be essentially the brain of our agent, we can write our first node. We'll define the assistant node. And remember that nodes and edges in Langgraph are really just Python functions. Nodes take in state and they modify the state and then return the state, whereas edges will take in the state and they have some logic to determine what node we have to route to next, but they don't actually modify the state. They simply return a string with the name of the node to go to next. So let's see that in practice. So we'll take in the state, which in our case is going to be of type scout state. And we're going to, just to be explicit here, return a scout state object. So that's how we would define a node in Langgraph. For the sake of this example, we'll do response is equal to LLM invoke, and we'll just say hi scout, and then we will append or modify messages by adding the response. And remember, when we invoke the LLM this way, the response that we get back is of type AI message already, right? So we don't need to grab the content attribute to get just the string, because in our state up here, this message is a list of base messages. So we actually want this entire object. And so we're just going to append that to the state messages, and we're going to return the state. So we're modifying the state messages key, and then we're returning that state. So if we call this assistant node, we need to pass in a state. So typically in Langgraph, the way you will see in a bit, the way you invoke a graph is by passing in a state and not just, for example, a message like when you invoke an LLM. So what we want to do is first create an initial state. And we've kind of already done that up here, so we can just use this. I'll remove that from up there and bring it down here. So this is going to be our initial state, and we'll get rid of that AI message. And so our initial state is going to have this first human message, hi, and the chart JSON string. And then we can pass it into this assistant node and invoke that. I didn't execute that. So we'll pass that in. After we've called the assistant node, what we get back is the scout state, as you would expect. What we can do is do result, and we'll go ahead and print that model dump, which just makes it easier to see. And so this is now the full state that's been returned to us, so as a dictionary. And so again, you can see those message blocks here, and here's the response from the AI. So now we see what the node, how the node works in action. We've passed in scout state. We've modified the scout state by adding the LLM response to the messages key, and then we're returning the scout state afterwards. So state in, state out. Okay, so we've got our state set up. We have the LLM, which is going to be the brains of our agent, and we have set up our first assistant node. But this isn't quite an agent yet. We have to define a full graph. To do that, we first will create what you call a graph builder, or what I'm just going to call builder here. And that is going to be instantiated from this state graph class. And to instantiate this state graph object, we have to pass in a state. So the state is going to be our scout state that we created up there. And once we have that, we need to start adding our nodes and edges. So the first thing we'll do is add our assistant node. You want to pass in the actual method or the function, and you can optionally pass, if you wanted to, a additional string which would change the name of this. So let's say we wanted to name this assistant, or better yet, just scout. then you can pass in this optional string, which is the name that you want this node to have. If you don't pass anything, then it will just default to the name of the function. So in this case, it would be assistant node. So we'll add that node there, and then we'll go ahead and add an edge. So remember that you always have to have a start node and then an end node. We have special keywords or special objects that we import from langgraph.graph. So in addition to the state graph, you have start and end. These are just convenience factors. So we don't have to actually add nodes for the start and end. Langgraph just kind of does that for you, but we do have to add the edges that tell it where should we go from the start node. So we'll say start, and then we'll say go to the assistant node. And then once we're done with that, we want to go from the assistant node to the end node. So we have our one node, we have two edges, and then to finish this off and get a valid graph, we have to compile this. And that's just going to make all of the connections and give us back a single object called the compiled state graph. And we can actually visualize this using this IPython display. And this is probably the most basic form of a graph that you can have. You have the start node. It's a normal edge, so no choice. You have to go directly to the assistant node. Can't pass go, can't collect $200. And then from the assistant node, you have to go to the end node. Okay, now to invoke this graph, it's going to again be graph invoke, but instead of passing in a message, you have to pass in a valid state. So what we can do is take this initial state from up here. And so this would be, let's say, our beginning state. And so we pass that in, and then we can invoke this graph. And what we get is that initial message, hi. And then the AI responds, hello, how can I assist you today? So that's how you would invoke the graph. The next thing we want to do is add tools. To do that, we're going to run a simple example up here. I'm going to go back up to where we defined our LLM and assistant node. And I'm going to define a tool up here. So to define a tool, we want to use the tool decorator from Langchain core tools. And this is just going to be wrapping the tool method so that it's going to extract the arguments that go into the tool. It's going to extract the name of the tool, the docstring that we're going to write, and then it's going to use that to build a tool model for tool messages and also to pass to the API. So it's really just a wrapper around the OpenAI API. Now this tool is going to be super simple. It's just going to raise the number A to the power of B, and every tool has to have a docstring so that the APIs understand what this tool does. So pretty straightforward. Now we can just run this to register that tool. Now we need a way to tell the LLM that it has access to this tool. So the way you do that, we need to call, and we can define it as a new LLM object so that it's separate from this original LLM that we created here. But we're essentially going to take that LLM and then we're going to use this method called bind tools, and we're going to pass it this tool here. And the way you want to pass it is as a list. And now this is this same version of the LLM. So it's going to use that same model and it has the same name, but it now has access to these tools. And so what I'm going to do is go into the assistant node, and instead of using this plain LLM, I'm going to use the one that has tools. So we'll go ahead and refresh that definition there, and then we can recompile the graph. And so here you'll see the graph still just shows one node for the assistant. we don't have any tool nodes in this graph, so we need to add them. There is a special way to handle tool nodes. The way you want to do it is by adding a node and then using this special tool node class, which is just a convenient way to instantiate this tool node. And what you can do is pass in the list of tools. The next thing we need to do is add our first conditional edge. It's going to come after the assistant node. So we're going to call it the assistant router. It's going to take in the state and it's going to return a string. So unlike a node, it's not going to be returning the state. It does not modify the state. It just takes in the state and then returns the next node. So how do we determine the next node? Well, we can look at the messages. Specifically, we'll get the last message from the state, which, remember, is just a list. So we can just call the -1 index. And then we want to see if that last message contains tool calls. So what we'll do is, if tool calls in last message, we want to route to tools. Otherwise, we will route to the end node. Why does this work? So when we go to the assistant is going to either respond directly to the user, in which case it's going to just simply add a message to the messages key, and that will get passed out to the end node, which will then be passed to the user. But if there was a tool call in that last message, then we're going to route it to the tools node, which is this node. And again, we can give that explicitly the name tools. Now we need to add a couple of edges. The first is this one that we've defined here, which is our conditional edge. So this is going to come after the assistant node. So conditional edges have their own method. So you're going to call this add conditional edge. We're going to pass in the first argument, which is the node that we're coming from. In this case, it's the assistant node. And then the function that we're using to define the edge. So in this case, it's the assistant router. Finally, you can either pass a dictionary or a list of the options. So this router for our conditional edge can either return tools or end. And so we are just specifying that in the list there. So once we add that conditional edge, we have now connected our assistant node to either the tools or the end. And so we can actually remove this one because now we're capturing that end node in this conditional edge. But we do need to route from the tools node back to the assistant node. And this edge here is a normal edge. So every time we go to execute a tool, we're going to follow up by going back to the assistant node. We want the assistant to check the output and see what comes out of the tools every single time so that the assistant can decide what it wants to do afterwards. So now if we run this again, we get a graph that looks like this. So our entry point is still from the start to the assistant node. Now you see those two conditional edges. The assistant gets to decide whether it wants to call a tool or respond directly, in which case it would just add its message to the messages key and then end the graph run. If it does go to the tools, then we'll run the tool, get a tool response, add that to the messages key, and then go back to the assistant node. And then the assistant can once again decide if it wants to call another tool or end the conversation. Actually, because the messages in our state messages are of type base message, they're not dictionaries. So instead of saying if the string tool calls is not in the last message, we actually want to do it this way where we're going to say if not last message dot tool calls as an attribute. So if it's an empty list, meaning there are no tool calls, then we'll route to the end. Otherwise, we'll go to the tools node. We also need to modify our invocation here. Instead of hard coding this string, hey scout, we want to now just pass in the messages. So our assistant node will look at the entire list of messages, so the entire message history, and then invoke a response based on that. So now that we have our tool set up with our agent, I'm going to run this again so that we can see it in action. So we're going to compile the graph, and we're going to initiate the same state as before with just a single message hi, and then we'll invoke the graph just like before. And if we look at the result, so our initial message is hi, we see the response, hello, how can I assist you today? Now I want it to actually use the tool. So instead of just saying hi, we'll say, hey Scout, what is 4.13 raised to the power of 8.16? Something that's difficult and not readily available online. And then we'll go ahead and invoke it, and hopefully we should see the result come back with the tool call. So let's scroll up. This is now a much longer list. So we see our initial message here. You'll see the AI message is blank right after this, our human message, but you'll notice that there are tool calls. So this tool call list is no longer empty. It is calling this function. The name is raise number to the power of, which is our tool. And then it's passing in the arguments for A and B here. And then this is going to, then we're going to invoke the tool in that tool node that we defined. And that's going to run the method and then get the output from that. That gets returned as a string, and we get this tool message that's appended to the history, which a tool message, again, is just another type of base message. And then finally, the tool call gets called, the tool message is added with the result, and that gets routed back to the assistant to then respond to. So that's this next AI message that we see here, and then we get the final response. So that's tool usage, and I want to hop over to Langsmith and I can show you what tracing looks like because it is super useful. Okay, so I'm in tracing projects, and remember that we called this only vans. We set that up in our environment variable, so I'm gonna click into that, and this has been running the whole time, so we have a lot of logs here, but at the very top is gonna be my latest run. So looking at the whole trace here, you'll see it broken down by each node. So we have our starting node here, then we have the assistant node, then we have the tools node, and then finally the assistant node. So that kind of follows the trajectory that we saw in VS Code. So from the start node, we're going to go to the assistant node, and the assistant node, you can see input and output, and that's true of every node. You can see the inputs and outputs to that node. In this case, the input, we have our chart JSON, which is that fixed string, and then we have messages, which just had our initial message. That gets passed into the LLM call, and here you can see what tools are bound to this LLM. So we only have one tool, and if you click on it, you can see the doc string as well as the input parameters A and B. You can see that it was called during this run. So Scout realizes it can use the tool for this. So the output here is going to be this tool call. So here's the name of the tool, and then here are the arguments. Now this is where the assistant router comes into play. It gets wrapped under this assistant node, but this is that conditional edge that we defined. And the input to this is the state. So you have the same format with the chart JSON and the messages. You'll notice that you have one more message added here. Before we initialized with just the human message, you have an AI message which is empty. But if we click on this drop down here, so this is kind of giving you a pretty print of this input object. You can look at the raw form, which is just a JSON object. And here you kind of see that familiar form that we saw when we did a model dump to JSON. So this is the JSON string. You have your messages key and the different messages. And if we look at the very last message, you'll see that it's empty, right? So it's an empty content, but this is the AI message. And if we scroll up here, you'll notice that this is the tool calls object that we're looking for. So there was a tool call to this tool here with the arguments here. So if we go back to this rendered form, that's why you see this empty message. So there wasn't any content, but there was a tool call associated with it. And so when we get to the assistant router, now it sees that tool call and it's going to return that string tools. So that's what's happening behind the hood. And now you can see why it's so important to have this type of tracing so you can follow all of the logic that's happening within the graph, especially as it gets more complicated. So since we know we have to go to the tools node, that's the next node that the graph goes to. We pass in those arguments to the function, which is executed in Python. And then this is the returned string that we get. And then we go back to the assistant node. And this time, after leaving the tools node, you'll see that the tool response has been added. And then we go back to the assistant and we add our assistant, our LLM response. And then we go back to the assistant router again. So this is going to happen every time we go to the assistant node. And in this case, it looks at that last message. There is content this time. There's no tool call. And so therefore we route to end. The last thing I want to cover is persistence and memory. So the last query we asked, what is 4.13 raised to the power of 8.16? And if I was to ask now, what did you just raise the power by? So ideally it would answer 8.16. Maybe this isn't the clearest question, but it should at least be able to reference one of those two numbers that we sent it, right? The response is I haven't raised a number to any power yet. So it doesn't have the context of the previous graph invocation. You can see these are all the messages. So there's no past conversation history here. It's just rerunning this from this initial message. And that's because we have no memory set up in this current graph. So the way Langgraph handles memory is the in-memory store is called memory saver. And that you can just think of as having a dictionary in memory that's going to store different values. So you can literally save the entire state to memory. And to do that, we're just going to pass that to this compile method. You can see it takes a checkpointer. So we'll say checkpointer and we'll pass in that memory object. So now when we compile this graph will have the ability to save our specific conversations or the entire graph run to a specific thread ID. And then in order to take advantage of this, we actually need config, which is going to be a dictionary, and it's going to require a key called configurable. And this is going to be another dictionary. And here we can pass in a thread ID, and this can be really anything, but let's just put 1. And all this is Langgraph taking in a thread ID. And so in the in-memory dictionary, it's going to save our entire graph run, so the graph state, to this thread ID. And so if we invoke a graph a second time, passing in the same thread ID, it'll be able to pull that conversation history and pick up where it left off. We have to pass this in whenever we invoke the graph. So we're going to add this as another parameter here and say config equals config. And so now let's go ahead and ask this question again. So now if we run this, we should get our normal response. We look at the result. We have the tool call. We have the tool response, which is 22.17. And then we have the final AI responding to the tool message. So now if I ask it, what did you just raise the power to? And then invoke this again without changing the config, because we're using the same thread ID, we should get a continuation of the conversation. And so here now you can see the full conversation history with the final answer being I raised 2.1 to the power of 4.15. And so now it does have the full memory and context of the conversation history. So that's how you can apply memory to your agents. This, of course, is the most basic example. You can get a lot more complicated with persistence by setting up a Postgres database and writing to it. You can also have memory caches in Redis. Those are more advanced topics that I'll cover in later videos, but that's memory. All right, so if you've made it this far, I hope you have a strong understanding of the core concepts in LangGraph, including state, nodes and edges, which comprise graphs, graphs themselves, how we add memory to graphs and persistence, and graph execution. Those are really the core things that you need to know to now be able to build agents yourself and really scale up the complexity from what we have here. You've seen how just having two tools in a super basic graph can make such a powerful agent. So hopefully your curiosity is totally running wild of the things you can build with this thing. I want to cover the final form of graph.py, and this is just going to be everything that you've already seen, but kind of cleaning up the code and making it more organized so it's easier to work with. I have the original state here, which you already know, and then the only difference is that we're going to put everything about our agent into an agent class. We're going to be passing in some initial arguments to set up this agent. This is where we're passing in the tools that we talked about. I'm not going to go into the details of how I implemented these tools. It's nothing new from what you've already learned. It's just a lot of code, but essentially the same thing, right? You have the query parameters that go in. Those need to be supplied by the LLM or the agent. And what you get back out is some result as a string. So that's true of every tool that you'll build. In this case, there is some complexities because we have to connect to a database. So we have, some SQL alchemy going on here to create an engine. And then we're going to query the database with this connection string and return the results in a data frame, which gets converted to Markdown. Similarly, with the generate visualization tool, the agent has to pass in some parameters, and then it's going to execute all this code, and then finally return some success message, which we're passing as a tool message here. So that's not the focus of this video, but if you are interested, I would definitely look through that code if you want an example of how you can implement some pretty complex tools. Also, feel free to build up on this and add a new tool to your agent and just import it here and add it to the list to kind of incrementally grow the functionality of this agent. I think that's a great way to learn. And let me know in the comments if you have any questions about the tool implementations or any of the other code. I'm happy to walk you through that as well. So the agent has that self.runnable. There's another method to inspect the graph, and then it has a method for invoking the graph, which you already saw. This is no different, right? You're going to call invoke on the graph, except in this case we saved it to the runnable variable, and then your input is just the initial state. Now this is something that we didn't cover, but you can either pass in the full state or you can just update one of the state variables, in this case messages, and then have the graph be invoked. So no difference there. And then this is a new method. This is just the same as invoking the graph, except we're going to stream back the responses. So this is how you get the streaming that we saw in the demo. And the only difference is we're replacing this invoke method with this stream method. And that's going to give us back some chunks, which we have to go through and parse. And that's what's happening here. We're going to filter out any tool calls that happen so we can do a pretty print of the tool calls, including the arguments. But yeah, that is the full agent that you have built, which you should hopefully have a pretty good understanding of everything that's happening behind the scenes now. So finally, if you want to play around with the agent, if you want to add some functionality or add new tools to your agent, you can then interact with it either locally using this chatlocal.py file. This is going to be in the front end folder. Or if you want to follow along in the next video where we actually deploy this agent, you'll be able to use this chat-deployed.py file, and this will interact with your deployed Langgraph server. But to chat locally, you can use this file, and this is just going to be importing that agent class that we created in the graph file. And you're going to have everything that we covered with the config and thread ID, allowing us to use memory, defining the agent, and then executing a while loop to interact and have each turn of the conversation. So that's everything. If you made it to the end of this video, you're amazing. Thank you so much for watching. Consider leaving a like if you got value out of this, and subscribe for the next video. Thank you.